Hi everyone. So this video is meant to kind of walk you through some of the mathematical work that we're going to need to do to solve problems related to gas laws. Gas laws are basically equations that are used to show relationships between the different properties of a gas. And the first one that we're looking at here, this video will cover problem 1, the gas intro worksheet. This one deals with Boyle's law, which governs the relationship between the pressure and the volume of a gas. As you hopefully saw in the video that I had you watch beforehand, pressure and volume are what we call inversely related. That is, as one increases, the other decreases. And the product of those two, when we multiply them together, will always be a constant. So as much as one increases, the other one will decrease by the same amount. And this equation that we see here, P1 times V1 equals P2 times V2, governs that relationship. So anytime you want to know how the pressure changes in response to a change in volume or vice versa, you can use this equation. And so what I'm going to do here is I'm going to solve this equation for the quantity V2, for the second volume. So we want to know basically what the volume is going to change to when we change the pressure by this. V2 is what we're solving for right here. And so the way we're going to do this is to get V2 by itself. So we want to see an equation that looks like V2 equals something. And the rule that we follow when we're solving algebraic equations is if we want to remove something from one side of the equation, we have to perform the opposite operation that we see in the equation itself. So here we see that on the right-hand side, as well as on the left, we multiply pressure times volume. So if we're multiplying in the equation, if we want to get rid of P2, if we want to get it to the other side, we're going to have to divide both sides of the equation by P2. So I'm going to go ahead and write that in here. I really like this pink color, not going to lie. And so we're going to divide both sides by P2. If we do that, then we cancel out P2, and the equation that we get that we can use to solve for V2 directly is going to be V2 is equal to P1 times V1, none of that changes, divided by P2. And so we very quickly know that if we know the initial pressure and volume where we start, and if we know what the pressure changes to, we can use this equation that we see at the bottom of our page here to solve for that second volume, to figure out what the volume changes to in the end. So that's problem number 1, dealing with Boyle's law. And now we have a different equation dealing with Charles' law. This was named for Jacques Charles, the French balloonist that actually figured out the relationship between volume and temperature. And basically what he found was that as the temperature increases, the volume also increases. This is what happens in a hot air balloon. When you heat up the air inside a balloon, the volume of that air increases and causes the balloon to inflate and causes the balloon to actually rise up into the air. What we're doing here is we're solving this equation, V1 divided by T1 equals V2 divided by T2, and we're solving it for T2. Now, this can be a little tricky on the surface because we have something in the denominator, in the bottom of the fraction that we're trying to solve for. But if we cross-multiply first to remove that fraction, then we're going to make our lives a lot easier. So I'm going to go ahead and do that. And cross-multiplying is exactly what it sounds like. You've done this before, I'm sure. We take V1 times T2 equals V2 times T1. And now it looks a lot like the first equation that we had for Boyle's law. And the way that we solve that last one, since we're multiplying on both sides here, is if we want to get T2 by itself, we have to get rid of V1. We have to get it to the other side of the equation. And since we're multiplying in the equation that we see in front of us, we're going to need to divide both sides by V1 to get T2 by itself and to get V1 to the other side. So again, T2 is equal to V2 times T1 over V1. And so again, if we know where we start in terms of both the volume and the temperature, and if we know what we want the volume to change to, we're going to be able to figure out using this equation what the temperature needs to be to make that happen. So I hope this helps kind of walk through the first two problems, and thanks for watching.